This webinar brings you a leading expert, Professor Fanendra, an esteemed faculty member from the Indian Institute of Science, to speak on this topic. Professor Fanendra is also one of our faculty members for AI in Healthcare Theory to Practice program, offered in collaboration with Indian Institute of Science and the Health Academy. Professor Fanendra is a distinguished expert in computational and data sciences, specializing in diffuse optical imaging, photoacoustic imaging, and MRI. His pioneering research has led to the development of innovative techniques and algorithms for biomedical applications, significantly advancing the field and reshaping the future of medical imaging. Today, we have the privilege of hearing from him. Before we move on, if you have this webinar is an interactive session and the Q&A and your chat box is enabled. If you have any questions, you may drop it in Q&A or chat box, and we will take up these questions throughout our webinar. So now, without further ado, let's welcome our speaker, Professor Fanendra.
Yeah, thank you, Srivalli, for that kind introduction.
Thank you.
Again, as Srivalli mentioned, so I have taken up this responsibility of introducing AI in healthcare. And of course, this is going to be a series of webinars where this part of the webinar or this session is focused on mostly on the introduction part. There are going to be AI tools and there are going to be learnings that is going to come up after. I think it is spread over a month from today. So without further ado, let me get started off on this. So again, I have few conflicts. I work with some of the companies, but there is no known competing financial interest for this particular work which I'm going to present. So I'm just going to put, the outline as I'll just put the little bit of the context of the webinar, and then I will talk about a little bit about what are the challenges in the healthcare. I think some of you already know this very well, but again, just for refreshing, I'll put that. I'll put importance of AI in healthcare and what are the challenges to implement certain AI in healthcare. And then I will leave it with AI in healthcare, some joint program which we are running with Astra Health Academy. Of course, most of my talk is going to be biased towards radiology because primarily I work in the area of medical imaging. So let me start off, and then just to set the context, we use AI as a very broad term. So first of all, I would like to define it very clearly such that we understand this little better throughout the webinar. So typically AI we call it as a superset. Any computer system which is out there, which is able to emulate the human intelligence, even let it be a rule-based system, you can call that as artificial intelligence. So in that, there is a sub-area called as machine learning. Again, these are all algorithms or statistical models which learn from the data which is there or the experience which is there, but it may not require so much of programming. Right? So then the third part is what is the current revolution of AI has been towards deep learning, and this deep learning uses what we call it as multi-layer neural network, and that is to design the structure and function of the human brain, and it will be able to mimic what human thought process or human intelligence or how the knowledge creation happens. In some sense. So if at all, if I have to say AI is a superset, machine learning and deep learning are subparts of it. And among the machine learning methods, there are deep learning methods and standalone machine learning methods. And then I'm going to give you a little bit of introduction to all this, and then leave you with a few examples here and there such that you understand what I'm talking about. Of course, I'm going to not speak more than about 35-40 minutes, such that we have time for a lot of question and answers. So by the way, what you hear most of the time is something like, what is called as autonomous driving. And for example, like Tesla cars, the autonomous driving that happens because of the computer vision. So they use computer systems to look at the imaging data and infer something from this to do certain tasks. So the computer vision has elements of AI, ML, and as well as deep learning into this. So you can also say something like ChatGPT, which is a natural language where you are asking a question in the language and it is able to answer in that language. So that means that it is able to do what we call it as the language processing. So those are also NLP is also one area where AI, ML, and as well as the deep learning has been part of it. Traditionally, whenever we looked at data analysis, we always looked at it from the tabular data point of view. So still the tabular data point of view is also still valid, but you can also use some of these automated methods like AI or machine learning or deep learning. And remember, whenever we talk about AI or machine learning or deep learning, this is equivalent to what we call it as data-driven approach. So that means that we use, these are all methods are based on the data. So that's why these are also known as data-driven approach. And these data, as I mentioned, natural language processing, tabular data, computer vision, these are all some of the areas where AI, ML, and deep learning has percolated heavily. So now again, I wanted to set the context from the healthcare point of view. The first thing which I wanted to say is that right now AI is transforming the healthcare, and because it is enhancing the diagnostic accuracy, treatment planning, and patient care. And the integration of AI in healthcare, this is very, very crucial for addressing current and future health challenges. So that's why you are also interested in this webinar, because these both are there, that is addressing the current and future challenges and transforming the healthcare. AI is one of such tool which can do both of them. So why do we require AI at all? So first of all, for that, I think we got to understand a little bit of challenges in the healthcare. So I might be repeating of what you know already. There is a shortage of healthcare professionals globally, and not only in India, but globally. So many regions face shortage of doctors. For example, if you think about rural versus urban, there is a lot more shortage in the rural compared to the urban. So that means that, if at all there is a shortage, then there is increased workload. And if there is an increased workload, there is something called as burnout. So because they got to see many more cases. And when you are burnt out, you are more poised to make mistakes. And more importantly, there is also rising in the healthcare cost. So for example, what I argue saying is that currently the healthcare costs are increasing more than the inflation rates in general. I mean, this is true even for India. So on an average, healthcare costs are growing up by 17 to 18% per year. And this is unsustainable. And when the healthcare costs go up, what happens is that a lot of the care which should be received is always looked at from the value-based point of view. And because of that value-based thing, there is a lot of pressure on the workforce to cut down on the cost. So, or to make it more efficient. So that means that they cut down on the workforce, or they cut down on certain things which has to be approved by the insurance agencies. So these are all the problems in the raising of the healthcare cost. And more importantly, I think in the recent times, thanks to all the digitization, we have a lot more administrative burden. So today, almost all healthcare professionals spend a lot of significant time in terms of paperwork, in terms of typing in the conversations which they are having in. So which also means that essentially they are reducing the time which is available for the patient care. So these are the current challenges. Ideally, we want them to spend more time in the patient care, less time on the administrative things. But today, at least the way the world is progressing, we are putting more emphasis on the administrative things and giving little less time for the patient care. So that's why the importance of AI comes. So because one of the first thing AI will be able to do is that it should be able to bring efficiency. That means that it can streamline all these administrative tasks. So as simple as whatever conversations you are having with your patient, if it can make a draft report, right, or a draft notes, you can easily pick that up and then edit it very quickly to be part of the HR, right? So that means that then you can focus more on the patient care. You can really have the conversations, and then it is going to generate a output which is going to be like a draft report which you can edit and do. So that means that it becomes more efficient. It also becomes accurate because the reason is that everything you are saying or everything patient is saying, in some sense, it is recording those. In some sense, you don't miss out anything that are there are the symptoms which have been told as well. Obviously, there is also enhanced diagnostics. There are these AI algorithms which can analyze. For example, I work in the area of medical imaging. There are quite a bit of algorithms that are out there which are able to do this medical imaging analysis and improve the diagnostic accuracy and also touch upon the early disease diagnosis. And more importantly, actually, this is where we call it as ultimate pinnacle. So, okay, you do the diagnosis, then what is intervention you should do? So that means that there is a personalized treatment plan. AI can help you in terms of developing those treatment plans based on whatever data which is available, based on the all the symptoms that has been recorded, such that we can improve the outcomes. So that's why the importance of AI is there, essentially solving a lot of the common day-to-day problems, including the higher level of the patient care and treatment plan and the lower level of administrative burden. It will be able to solve seamlessly. So this is where I keep talking about that. We have a development cycle for the AI application. So that means that anything you want to implement AI in your healthcare settings, so that you should have something called as identifying the need. So that means that, so for example, imagine that your need is that the chest X-rays that are being read out now takes about 5 minutes to be read, and you want to decrease it to 1 minute. So that means that the chest X-ray should be read in less than a minute. Earlier, it was taking 5 minutes. So you identify a need, saying that the AI should really be able to bring down 5 minutes of reading chest X-ray to 1 minute of reading. So that means that you describe what you are doing existing, and you define the desired target state. When I say define target state, that's what I meant, right? Bringing down from 5 minutes to 1 minute. And then you acquire or develop an AI system. I'll spend a little more time on this development and acquisition. And then once you have developed that AI system, you implement that in the target setting, that is in the clinical, and you monitor the performance. And if the performance is good enough, you maintain it. If the performance is reasonably okay, then you want to update it. And if the performance is going down, instead of reducing the time from 5 minutes to 1 minute, it is going from 5 minutes to 10 minutes, then probably you want to de-implement it. And then again, this cycle goes on. Right? So that means that you start off with a need. So that means that there should be a need where AI should be applied. And you should also understand what is the target state you want to achieve. That means that what is existing and where you want to improve, or where AI should help. And then you want to develop the AI system and implement and look at the performance. That's as simple as it gets. So now, what are the type of AI models? This is because introduction, I'm spending a little more time on this. So we call these models as supervised and unsupervised. So I will also give those examples to make a little more easier. But typically, the supervised means that we have something called as labeled data. So in very simple sense, we have something called as a ground truth, which is out there. And then we want to use it to train our model. So that means that in this supervised, we have two types of tasks. One, we call it as classification. Another one, we call it as regression. Classification means that we use the data to predict which category something falls into. So for example, you have a patient data and you want to know whether they are high risk or low risk. So that is the classification. You are telling whether they are high risk or low risk. Or you want to stage the tumor, right? Or grade the tumor. You want to know whether they are grade 1, grade 2, grade 3, or grade 4, or whether they are normal. So that is also a classification task. So that means that you assign them some label, and then you try to, whenever you get the data, you want to assign or put them into one of those bins which you have pre-selected. Now you can argue saying that how do you know the number of bins? That is based on the clinical knowledge which is already existing. Or the classes which you are choosing is based on the knowledge you have. So the other one is the regression. So that means that you use the data to predict something on a continuous basis. In the classification, you have very finite numbers. So that means that they should fall into high risk or low risk. That means that there are only two categories. Whether they should get into one of the grading of the cancer, that means that you have only 4 grades. So in some sense, that is all very finite. But in the regression, the values could be infinite. So that means that, for example, think about this like, predict the stock price of a company, given whatever data which is existing till now. So that means that we want to predict it for tomorrow. So tomorrow the price could be, let's imagine that till now the price is something like 299 rupees. So tomorrow it could be 300, 301, 303, 304, 305. There are infinitely such possibilities. So that's why we say that it is a regression, which is you are trying to identify a value. You are regressing a value. So that means that you make that prediction, which is infinite. Correct? So then there's another thing called as unsupervised. So in this case, you assume that you don't have this labeled data. So we call sometimes that you don't have a structured data. So that means that you don't have any idea what the result should look like. And that means that you are asking the algorithms to automatically identify the features which are hidden and cluster the data in a possible ways. In a possible way, it makes some sense, right? So for example, like the best example I can give is you have a genomic data, could you identify some pattern? Or you have a recording of the something like this webinar. Can you separate the voice from the noise, right? So that means that whatever is a noise or the background which is coming in, can you separate it out? So, and of course, this is, can you do it in an automated fashion such that I don't have any labels for it? So that means that there is no ground truth that needs to be marked for it. So that's what is this. So let me explain slightly better and in some sense, then if I do show it visually, it might make a little more sense.
Professor?
The supervised learning. So the reason why we call this a supervision is that there is supervision.
Professor Fanindra, I apologize to interrupt you. There is one question that is related to the previous slide. Why is it called as the regression data?
So because you are regressing, you are trying to identify a meaning. I mean, you are trying to identify a value.
Okay.
Does that make sense?
Okay, Professor. Yes.
No?
Yes, Professor. It does.
Okay. So now again, so let me explain this in a very simple fashion why it is called as regression. So typically regression is a statistical method which analyze what we call it as the relation which gives you on a one dependent variable. Or it could be one or more independent variables as well as a predictor. So in some sense, regression analysis tells us what will be the outcome or what will be the change in the outcome if the input data changes. So that means that, for example, you are trying to predict the stock price of a company based on all the historical data. Let's say that you have the data for last 100 days. So now, if you have it for last 200 days, does your result change? So that's a question. That's why it is called as regression. So we go back and we look at the previous data and try to predict something in the future.
Got
So
it.
that's why it is called as regression.
Thank you, Professor.
Okay, thank you. So now again, I want to go back to the supervised learning part. So the supervisor job is to give those labels. So for example, assume that you have the cow, camel, and elephant. And then who calls something as a cow and something as the elephant, and who calls something as a camel. So that is a supervisor. So that means that those who are experts will label that data. So that is there as the data set. So that means that we have some data and we have corresponding labels. So what we do is that we put it through an algorithm. This algorithm could be like machine learning algorithm or deep learning algorithm, and we process it. So the supervisor job is, given the training data set, the supervisor should give us the desired output. So now the algorithm, what it tries to do is that given this data set and output, it tries to match or develop a model or relation between them, right? So now when you give a new data, based on whatever it has learned based on the supervision, it'll try to give an output, right? So that means that what we do is, we have a training data set which is separated out from what data we want to test it on. And this training data set should have these labels for us. That's why it is called as supervision. So the other way around is that you don't have any labels, right? You have an unknown output. So that means that there is no training data set separately. You have only one data set, which is the input data. So then you try to find out whether we can naturally club all of them. So the naturally could be that, so those which are having horns on the top of the head could be a cow. The one which is having a long neck could be camel, right? So the one which is having a trunk could be elephant. So that means that we don't know whether it is elephant or camel or cow. So what we try to do is that we don't give a label, but we try to cluster them. So those who are having trunks should be put into one basket. Those which are having long neck should be put into one basket. Those which are having horns on the top of the head should be put into one basket. Now, who should pick up those features? I mean, how should we know that those are the features which are there? That is the algorithm's job. So the algorithm should learn those features. So that means that algorithm should understand that the difference between cow and the elephant is that elephant has a long trunk and cow has horns on top, right? Of course, there could be multiple differences. So it should be able to learn on this. That's why it is called as unsupervised. So we don't have anything called as training data set for this. So now again, when we do this, so the simple model development way is that you have some data which you collect quite a bit. And then you do some amount of cleaning up of the data. We call it a standardization. Or it could be like those features which you are extracting. And typically we split them into training and testing. So typical split is 80% of the data goes into the training and 20% of the data goes into the test. And then we build whether supervised or unsupervised. Because the training data is there, that means that if you are doing a supervision, so then we have the labels as well. We build a model and we test that model on the test data, which is also called as unseen data by the model, right? And typically in the healthcare, we split the train and test at the patient level. So when I say at the patient level, if you have 100 patients data, so we put 80 patients data into the training and 20 patients data into this. Of course, each patient can have multiple of them, right? So for example, assume that you are following a treatment planning. So they might have multiple time point data. So even then we try to segregate at the patient level. So now again, so you have done that development of the AI system. So then you go and implement that. And of course, before you implement, you want to evaluate whether it is good or not, but that we will talk some other time. So and then you may monitor the performance and then go back into the development side. Correct? So now, for example, what is the current state of AI? What is that it is currently able to do? So are there any things which have been already implemented? So for example, like I'll argue saying that there are already many clinical tools which are available. Those which are in green are the ones where US Food and Drug Administration has approved these AI products. For example, ECG processing, automated ECG processing, arrhythmia detection based on the ECG, or even on the Apple Watches, arrhythmia detection is there, which is actually FDA approved. Automated diagnosis, which is for specific targets. So there are a few things which are still under development. So for example, like AI-assisted pathology, patient screening from the total EHR systems, automated drug titration, automated diagnosis of something which is non-specific target, management and treatment is something which is not there. Of course, we want to reach that. So could we reach really the automated diagnosis is the ultimate aim. Of course, with that, we also want to get some clinical prediction, personalized medicine. Could we do AI-assisted interventions to a certain extent? Now again, so this is just to put the perspective that market size for the AI-driven medical diagnostics itself is about 2 billion. And then what is predicted is that it will grow up by another 15 times in the next 80 years to come. So that means that on a given year, it is growing at the rate of 40%. So that's why there are many, many key players which are willing to invest into this type of market. And again, just to go back into the history, so the first study that came out where AI was utilized in the diagnostics was for the breast cancer screening. So, and again, I need not tell you about breast cancer. It's the most common form of the cancer. And when this study was done, this was done way back in 2010, right? So, and always the screening tool that is used is always mammography. And what is most important in that mammography is that they want to distinguish between malignant and benign ones. Right? So because the malignant ones go up in the care cycle, they get a biopsy done, and then they look at the staging, and then they look at the treatment cycles. So in some sense, the early detection is always key in this kind of screening mechanisms. So what they have done is that they looked at about 62,000 mammographic findings, and then they build this artificial neural network, which is based on the deep learning. So in classifying something like, whether it is malignant versus benign ones, right? And then what it has proven is that the accuracy of such a deep learning model was 96%. And the typical radiologist accuracy was only 94%. Of course, the radiologist here they were comparing is having less than 5 years of experience. In fact, in the same paper, when they gave the same data to 15-year-old experienced person, so then it was able to bring it up to close to about 98%. Right? Of course, the confirmation is coming from the biopsy as well, whether it is malignant or not. So this got a lot of people excited. This was published in about way back in 2010, almost 15 years back, saying that the deep learning can really perform on par with a experienced radiologist who is having between 5 and 10 years of experience. So after that, there is a huge surge of things. Today, you have more than 950 AI products which have been approved by FDA. And in fact, out of them, about 75% of them are related to imaging based. So the radiology based products are more than 75% which are out there. Now again, so that is all there purely as a AI product, which we call it a software as a medical device. That means that AI alone is acting as a medical device. There is a lot of AI which is going into the medical device, right? So that is AI in the medical devices is also a big market, which you may not really see it as something, but it is already there. AI is there as a part of it. For example, in the 2024 alone, AI in medical devices market is that it is about $10 billion. And 2025, it is expected to go to 12 billion. And then by 2029, it is supposed to go to 35 billion. So with a growth rate of about 30%. So whether you want it or not, in the medical device industry, also AI is really making a big difference. Now again, this is something I keep arguing, saying that if at all you look at the value chain for AI, so I keep arguing, saying that if you have the data, of course, data is like the foundation, which you definitely require to do any AI-driven analysis or development of any AI-driven tool or AI-driven clinical system or AI in the medical device. But the data is there. Data is like the foundation. But of course, you cannot generate any revenue out of the data. So nobody will pay a rent for the foundation. Right? So people will pay what you build on top of it. The same way, what we do on top of it is what matters. So first thing you can do with the data is that in the diagnostic world, at least you can ask the question of doing the screening. Somebody has a lesion or not. This is a binary question you are asking. And if somebody has to pay for it, I mean, somebody means that if you ask the patient to pay for such an output, right? Or you can say that this is the outcome of the AI. You want AI to be paid. So typically that payment is around, I will argue, saying that $1 to $2. Because screening itself is kind of on the low level. And people don't really value that much as they value something like diagnosis. So that means that you go a little bit, we also call this as characterization. Now you are characterizing the disease. In some sense, you are saying that they have a grade 4 malignant tumor, or you are saying that they have this drug-induced interstitial lung disease. So in some sense, you are characterizing the disease, which is a little more specific. It is not like a binary question. It is like us doing a little bit more characterization. So typically, the outcome of that is, at least we argue, saying that is 10 times more valuable than the screening mechanism. And then, of course, the ultimate pinnacle is that it is in the treatment, right? So now, okay, you did the diagnosis. What is the intervention you do? So that means that most of the time, this is where we get the teams to work together. So that means that you want some recommendation about intervention to be done. So what is the Mr. Smith should receive such and such a specific treatment, right? So that is the ultimate value that is there for which AI is also. So in some sense, we want to reach to this pinnacle of treatment, and that gets you almost on par with the doctor's revenue. I mean, at least, you can make a little bit more money. But where we are in terms of this, so we are not really there in the treatment. We are not really there in the diagnosis. We are there in between screening and diagnosis. So that means that we are able to do a little bit of characterization. We are not really there in the diagnosis. So that means that we are past the screening. Until 2021, we were all working on the screening, because before that, standardization image analysis is all there. So the diagnostics is what is currently being developed. That means that the diagnosis part is what every one of us, including me, we are trying to figure it out. Could we do the diagnosis? Of course, ultimately having the treatment planning, in my view, this is my view, is that 5 years down the line, you might see that. Right? So that means that around 2030, you can see that this autonomous treatment plannings coming out of the AI might be a reality. Again, that is being very efficient. So now what is the challenges for this AI in the diagnostics, right? So if at all you ask me, so I will argue saying that, the data itself is a thing, right? So for example, you want to develop a deep learning model, or you want to reduce the time of chest X-ray reading from 5 minutes to 1 minute. So the first question to ask is that how many patients' data do we require to do this in the one of what we call it as how many patients' data do we need in the supervision sense, or even if you have to do unsupervised, how much data do we require, right? So and nobody knows that answer. Again, all of them are big research questions. So now let's assume that somebody said that you require 300 patients' data, and you are one of those who is working on a very, very rare disease. What happens if you don't have 300 patients' data? And then the second question is that, okay, you have the data, but you don't have the supervisor, or you don't have the expertise to annotate them or to label them. So what happens if you don't have enough annotations? So now again, these are all big questions, and I don't think I have answers. Even now, these are all still open questions at this point of time. There are certain solutions which are there, which are trying to solve it, but not a complete solution. In terms of the models, should we use AI? Should we use machine learning? Should we use deep learning? The first question is, do we really need deep learning models? Because they require a lot more data compared to machine learning. So, and is there any off-the-shelf models? Is there anything which I can just bring it in and plug and play? How can we incorporate context or prior into these models? Because most of the diagnosis happens with the prior information or within that context. So how do we bring that to the AI as well? Is there anything which we can make it patient-specific or user-friendly? And in terms of the results, so let's say that AI said that it is a grade 4 tumor. So can we visually interpret why it has said it is grade 4? Can we obtain a human-friendly interpretation? This is part of the explainable AI. And again, that is also a big area by itself. And as I said, in terms of the questions we asked for the data, in terms of the questions we asked for the model, in terms of the result we have asked, I don't think we have answers for any of them, right? So we have some partial answers. Still, it is an evolving field in that area. And now let's assume that you have somehow this experience of creating that, and then you know this. So then what are the challenges to create that kind of models? So I'll argue saying that the first thing comes from the data privacy and security. So when I say the first thing comes from the data privacy and security, so the DPDP Act, which is Data Protection and the Digital Privacy and Data Protection Act, has come out in 2023 and it became a law. So that means that anything digitally we are collecting, there is a new regulation in India. And of course, every patient data you are collecting, you have to have some ethical board approvals. So that means that you cannot simply collect the data as you like. You need to follow certain procedures. And there is a bias in the data, whether you want it or not, because certain amount of population or the genders or the economic sectors are what is very specific to a hospital. So now if you want to have very diverse data set, then you need to do a multi-center kind of data collection. Right? So that's one issue. And today, AI is considered as a black box. There is a lack of transparency, or nobody knows what is happening. So there is a trustworthiness issue there. And then regulation and governance has become another issue. How does AI get regulated? So now you can argue one way is that AI is like a calculator. I should be free to use it. You can also ask other way around that AI is driving the care, so then it should be carefully evaluated. So there are these questions, right? The adaptation is still a thing, and more importantly, there is quite a bit of misconception, right? So in some sense, there is a lack of understanding from both from the user's point of view and as well as the patient's point of view. How does the AI work itself, and what it can and cannot do, right? So you should have a realistic expectations. So then if you have unrealistic expectation and if it doesn't work, then we have the mistrust that happens, right? So then that is a fundamental problem we have. So, and again, I have been working in this area for more than close to about 8 years. So we thought that, we should at least, make the people understand a little bit more about AI. So we started this program with Astra Health Academy in about 3 years back. And we have completed about 4 batches. It's a very structured learning for healthcare professionals. And in fact, there's going to be more details that will be given. It's a very comprehensive hands-on program offered by Astra Health Academy in collaboration with IASC. And we really make it very tailored for healthcare professionals. And then I think that right now the batch 5 enrollment is going on with a tentative starting date of starting it in around May 1st. And if those of you are interested in the link, I think they will post the link again in the chat box as well. You can again have a look at it as well. So again, from the instructor point of view, we have a good team. So I will argue saying that Dr. Lokesh, who is at the Astra CMI, is also one of the instructor. We have been collaborating with him on multiple AI projects. So I am there. Ambedkar is another professor from computer science. Vanati is another professor from our department. We have 50 hours of contact. We have a lot of practice sessions. We also have campuses. And most of them are live classes. So now again, it is targeted at healthcare professionals, and then that program is about AI technologies for the healthcare, and they should be interested in practical implementation, building to train continuously, and then they should not be afraid of change, because AI is going to disrupt whether you want it or not. And ideally, you should be willing to learn, ideally, and get heart and student in mind.